Okay, so let us start. We were finding the controllability and observability of the sequential circuits where we had the D flip-flop and we worked for first pass of calculating the controllability. The top line indicates the combinational controllability for 0 and 1 and the bottom line indicated the sequential controllability for 0 and 1. These ऊपर जो लिखे हुए हैं, these are the line numbers or the lines or signals. The input signal is A and clock, right? So we initialized the inputs, the primary inputs A and clock with combinational controllabilities of 1 1 and sequential controllabilities of 0 0 and worked as we did in the previous cases for finding the controllability for the following signals. Only thing to indicate or to remember here is that the output of the flip-flop or all the lines initially are put in with the controllabilities of infinity. Sequential controllability भी और combinational controllability भी. So the initial value of the output of your flip-flop E and I, दो flip-flops हैं, E ये रहा and I ये रहा. So these two are put to infinity. Rest every signal is evaluated to calculate the controllability for combinational and sequential controllability. Now let us look at the second pass. These were the values which we obtained after the first pass. To work with the second pass, we work with the primary values. Primary signal के values will be same because इनमें कोई भी change नहीं आएगा with the n number of passes. Therefore, the value of A, controllability of A will remain as it is. Similarly, controllability of clock will remain as it is. Now we start evaluating for the rest of the signals. So first we begin with the output of the flip-flops. That is E and I. So we try to evaluate what is the value of E and the value of I in the second pass. Let us look at E first. If we look at the formula for the controllability of the D flip-flop, settle down first. Here we are not having any reset signal in the flip-flop, so this part will not work. So reset does not work. Therefore, we do not have this part, the first part in the equation. So only we need to analyze is CC0 at Q will be given as the controllability at D for 0 plus the clock H. So if I work down here and I work with E, the value of Q or E will be equal to 0 only if the D value is 0. Right? So CC0 of H plus CC0 of clock plus CC1 of clock. So I say CC0 of Q will be given as CC0 of the input, which is D, that is your wire H, plus CC0 of clock plus CC1 of clock, because at the clock edge the data from D will be passed on to Q. So 0 at D will be passed on to Q. So what will be the value of E now? The combinational controllability. H का कितना है? H का है 7. CC0 is 7 plus CC0 of clock, which is 1, plus CC1 of clock, which is again 1. So it means 7 plus 2 is 8. So the controllability CC0 for the signal E will be 8. Right? What will be CC1? यहाँ पे हम केवल 1 यूज कर लेंगे. CC1 of Q will be CC1 of D plus the clock. So what is CC1 of wire H? Here, this is infinity. So CC1 of H plus CC0 of clock plus CC1 of clock. So this will give you infinity again. So the value will be infinity. ये 8 नहीं 9 है. Because we had 7 here plus 2 of this clock. So this gives me 9. What will be the sequential controllability? SC0. Again the same way. SC0 will be SC0 of H plus SC0 of clock plus SC1 of clock. Right? And plus 1 आएगा क्योंकि sequential controllability है. So what will it give you? 0 plus 0 plus 0 plus 1. So it means 1. कॉम्बिनेशनल के लिए नहीं होता है. जब हम सीक्वेंशियल सर्किट्स की बात कर रहे हैं तब यहां पर 1 नहीं आएगा. बट फॉर द फॉर्मूला ऑफ डी फ्लिप फ्लॉप जब हम सीक्वेंशियल कंट्रोलेबिलिटी की बात करते हैं तो प्लस 1 आएगा. ठीक है, नॉर्मली नहीं आएगा. कॉम्बिनेशनल कंट्रोलेबिलिटी फॉर सीक्वेंशियल सर्किट विल नॉट बी 1, but sequential controllability for sequential circuit will have addition of 1. What will be SC1? SC1 of H, that is infinity, plus 0 plus 0 plus 1. So that would be infinity only. So it is 1 infinity. Right? This is the output of first flip-flop. Similarly, analyze what will be the controllabilities for output I. Quickly work out for I. What is this combinational controllabilities first? The input to this flip-flop where I am calculating I is D. So you will look into the values of D with clock. So CC0 of I will be CC0 of D plus the clock. So 3 plus 2, 5. What about CC1? CC1 कितना आएगा? 3. D की it would be 0 plus 1 plus 1 or okay, so 2. D का 3 0 था. D का 3 infinity था. 3 infinity. This should have been infinity. तो ये 2 नहीं होगा, कितना होगा? Infinite होगा. So this is 5 infinity. What will be the sequential controllability? Sequential controllability of input plus that of clock plus 1. How much? 1. Sequential controllability of the input, that is small d, plus that of the clock. So 0 plus 0 plus 0 plus 1. So that should be 1. What about SC1? Infinity. Right? Now I have the output values of E and I. These will be propagated towards the input. So ये I जो है मेरा, this becomes my input to level 1. Right? So now I again start from level 1 and move towards level 4. To start analyzing, I now have the controllabilities for I as 5 infinity and 1 infinity. What about C? What will be the value of C? नॉट गेट का आउटपुट कैसे करते हैं? C0 कब होगा? जब उसका इनपुट 1 होगा. तो इनपुट के 1 होने की प्रोबेबिलिटी, इनपुट के 1 होने की कंट्रोलेबिलिटी इज infinity. So this will be infinity. Right? When will be the output of NOT gate equal to 1? When input is 0. So what is the controllability of input? 5. So it should be 5 plus 1, 6. Fine? एक और? अच्छा, C का आउटपुट 0 कब होगा? When will C be equal to 0? When the input of NOT gate is 1. So what is the controllability of setting it equal to 1? Infinity. हम इस तरह से लिख रहे हैं ना, combinational controllability of 0, combinational controllability of setting equal to 1. ऐसे ही sequential controllability of 0, sequential controllability of 1. So if I want to set a value equal to 0 at C, I need to set or control the input to be 1. So that is infinity. So infinity plus 1 according to the formula, plus 1 for level change. So combinational controllability में plus 1 होता है. So infinity plus 1 is infinity. Then CC1 at C will be, C1 कब होगा? जब input, that is I, is 0. So look at the combinational controllability of input, which is 5. Add 1 to it. 5 plus 1 gives you 6. So now the controllability for the signal C is given as infinity and 6. Okay? Now find the sequential controllability at C. Sequential controllability same उसी तरह से, C will be 0 when the input is 1. So 1 के लिए controllability is infinity. So it will directly be infinity. And SC1, C will be 1 when I is 0. So look at the controllability of 0. CC0 is 1. Right? So this becomes 1. ठीक है, केवल D फ्लिप फ्लॉप में +1 होगा, बाकी सब में से +1 हट जाएगा. So I write only 1. Look at the second gate at the same level. This is gate number 1. So we analyzed for B. B is simply dependent upon A. A is a primary input. Primary input की controllability में कोई change नहीं हुआ है. So B will remain the same. Otherwise you can calculate as well. B will be equal to 0 when A is 1. So B की controllability for 0 is given as A की controllability for 1 plus 1. So that is 2. Similarly, I can calculate these values. B will not change. Right? C we have evaluated. Now move to the next level. When I move to the next level, I am talking about the signal D. So calculate that for D. What is the controllability for D? CC0 for D. D0 कब होगा? जब दोनों इनपुट्स 0 होंगे, B और C दोनों 0 हो जाएं. यानी टेक CC0 of B plus CC0 of C plus 1. So what is CC0 of B? It is 2 here. CC0 of C, infinity, plus 1. So the resultant should be infinity. Why is my coming out to be 3? कंडीशन गलत बोली मैंने. D0 कब होगा? जब दोनों में से कोई भी एक इनपुट 0 हो जाए. राइट? एंड गेट है तो D0 कब होगा? जब दोनों में से कोई भी इनपुट 1 हो जाए. राइट? सो वी टेक द मिनिमम वाला इक्वेशन. मिनिमम क्या रहेगा? इसका तो है 2, इसका है इंफिनिटी. सो द मिनिमम वैल्यू इज 2 plus 1. That gives me 3. So this gives me CC0 as 3. Now CC1 for D. D1 कब होगा? Both inputs are 1. इसका मतलब दोनों का CC1 will be added. So what is CC1 for B? 2. CC1 of C 6. So 8 plus 1 और आएगा. तो यानी 9. Right? Calculate the sequential controllability. Same way, बस plus 1 नहीं करना है. तो जीरो कब होगा? जब दोनों में से कोई भी एक इनपुट जीरो हो. सो टेक द मिनिमम ऑफ दिस. जीरो और इंफिनिटी से मिनिमम इज जीरो, राइट? सो द वैल्यू विल बी जीरो. प्लस वन नहीं होगा क्योंकि सीक्वेंशियल कंट्रोलेबिलिटी कैलकुलेट कर रहे हो. व्हाट इज एस सी वन? वन. द मिनिमम ऑफ एस सी वन ऑफ बी एंड एस सी वन ऑफ सी. इन दोनों में से मिनिमम इज जीरो. तो फिर वन क्यों आया? ओके, दोनों होने चाहिए. सो सम दैट वुड बी वन. So level 2 evaluated. Now work for level 3. Work for level 3. Let's talk about F. F is the output of NOR gate. NOR gate ka truth table is here. This would be 1. Rest everything is 0. So if I want to have controllability of 0 at F, what should be the condition? Any of the input should be 1. So take the minimum minimum CC1 of input. Input कौन कौन से है? A, D, तीन है. A, D और ये E. बीच वाला वायर is E, ऊपर वाला is A and the lower one is D. So you consider A, D, E. So A is here, D is here and E is here. So what will be CC0 of F? Minimum 3, 9 और 1 में से minimum 1 plus 1 2, right? What will be CC1? CC1 क्या होगा? दोनों या all the inputs should be set equal to 0. So take the sum of CC0s of all the inputs. CC0 of A is 1. CC0 of D is 9. No, 3. And this is 9. So the minimum is 1. 1 plus 1 is 2. So F का हो गया 2 2. अरे दोनों साइमल्टेनियसली होने चाहिए ना. 1 के लिए all the inputs should be 0. So you should take sum. So 0 plus D. D is 3, that is 4. और E is 9. E was 9. सारे इनपुट्स साइमल्टेनियसली 0 होने चाहिए फॉर योर नॉर गेट आउटपुट टू बी इक्वल टू 1. साइमल्टेनियसली मतलब यू एड दोज वैल्यूज. सो CC0 ऑफ A प्लस CC0 ऑफ D प्लस CC0 ऑफ E. So 9, 10, 11, 12, 13 और plus 1 is 14. Calculate SC0 and SC1. We are talking about this F, right? F will be equal to 0 when any of the input is 1. So take CC1 of these three inputs, take their minimum. So ADE CC1. A का 1 is 1, sequential. A का SC1 is 0. What is B का SC1? 1. What is E का SC1? Infinity. What is the minimum value? 0. So the value here should come down as 0. For SC1, when will output be 1? Output will be 1 when all the inputs are 0. So you should add all the SC0s of input. So SC0 of A plus SC0 of D plus SC0 of E. So this means 1. So the sequential controllability of wire F comes out as 0, 1. Now evaluate for this wire. For level 3 AND gate, calculate what will be the controllability for G. पहले combinational, फिर sequential. कौन कौन से इनपुट्स कंसिडर करोगे? E and D only. दो इनपुट है AND गेट के, E and D. So AND गेट का ट्रुथ टेबल, all input, all output 0 except for last, right? This Z is same as G because Z is fan out of G. So what will be the when will be the output equal to 0 for an AND gate? जब कोई भी एक input 0 हो जाए. So for all the inputs, find the minimum CC0. So we are talking about D and E. CC0 of D in this pass, always take the value in the current pass. So CC0 of D is 3, CC0 of E is 9. So the minimum is 3. So 3 plus 1 gives you 4. So the first value is 4. What about CC1? आउटपुट एंड गेट का 1 कब होगा? जब दोनों इनपुट 1 हो जाएंगे, यानी CC1 added for all the inputs. So D का CC1 is now 9. E का CC1 is infinity. So it means infinity plus 1 is again infinity. So the value is 4 infinity. Right? जब हम कह रहे हैं ना हमारी controllability is infinity, it means you will never be able to set this value. Right? 0 means फटाफट कंट्रोल हो जाएगा, डायरेक्ट कंट्रोल हो जाएगा. बट अगर हम इंफिनिटी की तरफ जा रहे हैं, इट मीन्स इट इज मोर एंड मोर डिफिकल्ट टू कंट्रोल दैट वायर्स वैल्यू. सो इट इज राइट नाउ नॉट पॉसिबल टू कंट्रोल द वैल्यू ऑफ G in the second pass. It may be possible in the next pass, but it might happen that it is not possible to control the particular wire. Right? Find out what is SC0 and SC1 for G. 0 का जब कोई भी एक 0, so take the minimum of SC0s at input. So 0 and 1 का minimum is 0. So the value is 0. What about 1? जब दोनों inputs 1 होंगे. So 1 plus infinity, again infinity. So it is still 0 infinity. ठीक है? Now come the next level, level 4. Level 4 का output is H. So control for H. Find SC0 for H. This is a OR gate. OR gate का output 0 कब होगा? जब दोनों input 0 हो. So input के CC0 का sum. What are the inputs here? F and G. So CC0 of F plus CC0 of G plus 1. So 4 plus 2 is 6 plus 1 gives you 7. When will be the output H equal to 1? जब inputs कोई भी एक input 1 हो जाए OR gate का. So it means you take the minimum of CC1 at input. So 14 infinity. The minimum is 14. Add 1 to it. So that gives you 50. What is the sequential controllability? Output 0 कब था? जब दोनों 0 हो. So SC zeros का sum of inputs. So 0 plus 0, that gives you 0. 1 कब होगा? जब कोई भी एक input 1 हो जाए. So take the minimum of inputs. 1 and infinity, the minimum value is 1. So the answer is 1. Right? This is second pass. We will have to keep on doing it until the values become constant. ठीक है? अभी कुछ values constant हुई हैं. A का value is same as the previous pass. B का value is same as previous pass. But the value of C is updated. even D is updated. Some values have been updated, some are as it is. So we will continue until all the values become constant. So it means we need to go for the next pass and check if the values have become fixed or not. So work for pass 3. Again for third pass, you will have to evaluate the output of the D flip-flop in the beginning, so that these values are given as input to your level 1. So the first thing that we evaluate is the controllability for E followed by controllability of I. So find out what is the controllability for E, combinational controllability. E 0 कब होगा? जब input 0 हो और clock edge आए. So input 0 means this value of D is 0. So that is CC0. किसका? H wire का. So what is H wire here? Here. ये रहा H. So CC0 of H plus clock edge. Clock edge मतलब एक बार clock 0 consider करो, एक बार clock 1 consider करो. So what will be CC0 for E? 7 plus 1 8 plus 1 9. Right? CC1, the output of the flip-flop will go to 1 after the clock edge and the input has to be 1. So input 1 means wire H, 15. 15 plus clock, so 16 and 17. So this becomes 9, 70. ठीक है? Sequential controllability इसमें +1 आएगा. D flip-flop की sequential controllability में +1 आएगा. So what will be the value of SC0? 0 plus 0 plus 0 plus 1. That is 1. SC1 1 होना चाहिए इनपुट पर और क्लॉक एज होना चाहिए. So 1 plus 0 plus 0 plus 1. That is 2. So the value of E comes out to 1, 2. Now similarly evaluate for I, the output of second D flip-flop. What input should you consider? D. So consider D. D is here. I 0 होगा जब D 0 हो and clock edge हो. So 3 plus 1 4 plus 1 5 and 1 for controllability. So 6. नहीं उसमें sequential controllability में 1 आता है. So this will remain 5. When will be the output equal to 1? जब input 1 हो plus clock edge. So 9, 10, 11. So 5, 11. Sequential controllability इसमें +1 आएगा. So 0 plus 0 plus 0 plus 1. So that is 1. And SC1 will be 1 plus 0 plus 0 plus 1. That is 2. Right? Primary inputs same रहेंगे. Nothing changes in primary input. So the primary inputs are A. So it still remains 1 1 and sequential value is 0 0 and the clock is the primary input. So it becomes 1 1 and 0 0. Now start evaluating with level 1. ये जो I का value है that is seen at the input of this NOT gate which is 5 11 1 2. Using these input controllabilities, find quickly the controllability for C. When will C be equal to 0? जब I 1 हो. 1 की controllability is 11. So 11 plus 1 gives you 12. C1 कब होगा? जब I 0 होगा. So I 0 की controllability is 5. 5 plus 1, 6. Right? Calculate the sequential controllability. सिर्फ plus 1 नहीं होगा. So for C equal to 0, I should consider SC1, that is 2. For C equal to 1, I should consider SC0, which is 1. So 12, 6, 2, 1. Right? Another gate at the same level. Find out what is B. It will remain the same since it simply depends upon A. A has not changed. So you can evaluate again. This will also remain the same. 2, 2, 0, 0. Fine. Level 1 completed. Go to the gates of level 2. Level 2 is this AND gate. So evaluate for D. When will D be 0? जब कोई भी एक इनपुट 0 हो जाए. So use the controllabilities for wire B and C. Here, ये रहा B, ये रहा C. When either of the value is 0, so take the minimum. So 2 or 12 का minimum is 2 plus 1 gives you 3. What will be CC1? जब दोनों 1 हो. So 2 plus 6 is 8 plus 1 gives you 9. Right? Sequential controllability. 0 और 1 में से मिनिमम 0 और 1 के लिए दोनों 1 होने चाहिए. तो 0 और 1 1. पहले वाला 0 और 2 था. Any one of the input should be 0. So minimum of 0, 2 gives you 0. Hence you put 0. Fine. Level 2 completed. Go to level 3. Work for F. F के लिए inputs that you should consider are A, D and E. So consider the inputs A, D and E and find out what is the controllability. You should consider A, you should consider D and E, these two. F will be, yes, 2. टू के बाद 14. 14. What about sequential controllability? कोई भी एक इनपुट 1 कैलकुलेट करो. मिनिमम ऑफ 1s 2, 1 और 0. सो मिनिमम इज 0. 1 कब होगा? जब सारे 0 होंगे. सो एड SC0 फॉर ऑल. सो 0 plus 0 plus 1. 1. Right? What is the other gate at the same level? AND gate. AND gate का output is G or Z. So evaluate for G. Calculate combinational controllability. OR gate का output 0 कब होगा? जब सारे input 0 हो. So add CC0 for F and G. नहीं, G तो हम निकाल ही रहे हैं. E और D के लिए consider these. Output will be 0 when both the inputs are 0. So 9 plus 2, 11 plus 1, 12. नहीं, we are talking about AND gate. AND gate का output 0 होगा जब कोई भी एक input 0 हो जाए. So we should take the minimum. कितना आएगा? Minimum of D and E. Minimum is 3, add 1, that gives you 4. What is CC1 now? सारे इनपुट 1 होने चाहिए एंड के. So 9 plus 17, 26 plus 1, 27. What about SC0 and SC1? 0 है ना. और नेक्स्ट 3. ठीक. All the gates completed at level 3, go to level 4, evaluate for H. H is the output of a OR gate. When will H be 0? जब दोनों इनपुट 0 हो, यानी F और G कंसिडर करना है अब हमको. So these two, both the inputs are 0, so 4 plus 2 is 6, plus 1 gives you 7. Output will be 1. OR gate का output 0. Both the inputs are 0. Output will be 1 if any of the input is 1. OR gate. है ना. हाँ, पहले 0 के लिए. 0 means both the inputs should be 0. So what are the two inputs? F and G. So use CC0 of F, which is 2, CC0 of G, which is 4. So 4 plus 2, 6 plus 1. So gives you 7. Now the output H will be equal to 1 when any of the input is 1. So it means you should take the minimum of CC1 for both the inputs, which gives you 14. Add 1 to it. This gives you 15. So 7, 15. What about the sequential controllability? Again, the output is 0 when both the inputs are 0. So you add 0 and 0. That gives you 0. Output will be 1 if any input is 1. So you take the minimum, which is 1. No, F and G. Minimum, which is 1, right? 1 or 3 mein se. So the value will be 1. So I have evaluated all the signals in this pass. Still some of the values have been updated. For example, E has updated. So it means we should check for the next pass again and see if the values have settled down to become constant values. We'll do the same exercise for 4. First thing that you do is for E and I, right? You will now get that all the values in pass 4 will come out to be equal to the values in pass 3. I leave it as an exercise for you. You can check it by yourself. All the values in pass 4 will come out to be same as that in pass 3. Evaluation sequence would be, first thing is you find out what is E. The second thing is you find out what is I. Then you put the primary inputs, that is A and clock. Start analyzing for level 1. Take this input I to the NOT gate and evaluate for D. So fourth step would be calculate for D. Calculate for C. Then fifth step, calculate B. Sixth step, calculate D, followed by F, followed by G, followed by H. Use this pattern, use this sequence, you will get all the values to be same. Since all the values have become constant, we say that this is my final controllability. I am able to control all my signals for this case. The controllability highest value is 27. So it is most difficult to put a value of 1 at wire Z. Right? In the next class, we will work out for the observability, combinational and sequential for this circuit, right, tomorrow. Any problem in today's class? Just give a try to calculate the values of pass 4. Since the values you already have, it will come out to be constant. Just try to get those constant values. That is all for today. I am ending the class.